Video on exponential equations. So exponential equations, you will recall from last week that the equation I use for exponential equations is y equals a, where a is our starting value, okay, meaning when our x input is 0, b to the x, and b is called our multiplier. So anytime, just like with a linear equation, when I have a linear equation, meaning we're adding or subtracting a number repeatedly, I need to have the starting value and I need to know my rate of change or my slope. Those are two things or two parameters that I need to write a linear equation. So an exponential equation is very similar. Same thing, I'm going to need the starting value. So I'm going to need to know what is my output when my x is 0. And then instead of needing the slope, I need to know the multiplier. What is the common number that's been multiplied repeatedly? Okay, so let's look at a couple of examples. So right here, I have a picture of a graph. I know it's a little bit hard to see the scales on this graph, but I'm going to let you know that it's going up on the y-axis by 3, and the x-axis is going by 1s. So just looking at this graph visually, I'm able to see where my starting value is. It looks like my starting value is right up here, and if I were to count that up by 3s, it looks like that is at 27. So I'm going to go ahead and just start over here. I'm going to put y equals, I've got 27, b to the x. Okay, and I don't have that multiplier. All right, so let me look at some of the other points. Now I'm noticing that this is definitely decreasing, so that means it's going down. It's an exponential decay or decreasing function. So I'm just going to look at some of those other points, and I'm going to go ahead and just put those into a table so that I'm able to see them a little bit more clearly. So I'm going to go ahead and put, so here's my x. Now that yellow's a little bit hard to see, and this is my x, and this is my y. Okay, so we already had the point at 0, and we had 27. And then I'm going to look at, it looks like this next point right here is at 1, 9. And it looks like this third point is at 2, 3. Okay, so hopefully I'm looking at this and I'm noticing that because it's going down, I must be multiplying by a number less than 1. And it looks like if I looked at it, right, I can see that if I went this direction, we're timesing by 3. So since I'm going this direction, I'm not timesing by 3. It looks like I must be multiplying by its reciprocal. I must be multiplying by 1/3, because 27 times 1/3 would be 27 over 3, which is 9. And then 9 times 1/3 would be 9 over 3, which is 3. So my multiplier is 1/3. So I'm now going to go back to my equation. And I am just going to go back and change that multiplier to, and let me get that done. Nope, that's not what I wanted. All right, let me 1/3 to the x. All right, and I am done. There is my equation. That's going to represent that exponential function. All right, so again, I need my starting value and I need to know what my multiplier is. All right, let's look at another example. All right, so here I have a table, and I'm noticing at week 1 I have 756. That's the weight of the bacterial culture. and then week 2 it's gone up, not very much, okay, and then week 3 it's gone up as well. So I must be multiplying by a number that's larger than 1 since it's increasing. So I don't have my starting value in this problem. So I'm going to switch gears and find my multiplier first. So in order to find my multiplier, I have to see, well, what number, right, has been multiplied from here to here? I could try a guess, but I also know I could do 793.8. So I'm going to do that right up here. I could do 793.8 divided by, not question mark, divided by 756. And when I do that, I end up getting, I would just go to Desmos to do that, or I'd go to my Chromebook calculator and do that. And when I do that, I end up getting, let me go ahead and do that real quick, 793.8 divided by 756, I'm going to get 1.05. Okay, but I'm not sure that that's the actual, that if that's still the multiplier. I've just tried it once, so I need to actually go ahead and do that again. So I'm going to do 833.49, and I'm going to divide that by 793. And when I do that division, thankfully, it ends up being 1.05 as well. So it is increasing, not by much, because if I times by 1, it would stay the same, but I'm times by 1.05, so it is increasing a little bit each time. And I could go back and double check that. Okay, I could do 756, so I could do from here to here. Okay, I could times that by 1.05 and see if I'm getting, right, 793.8. And then I could also do the same thing, right, times it here. So if I do that, I see that it is consistent. So I do know my multiplier. My multiplier is 1.05. All right, so how am I going to find my starting value? Well, if each time I'm going up a week, so for example, if I wanted to find week 4, I could do 833.49 times 1.05. Okay, if I wanted to do week 5, I could times that again by a 1.05. So if I'm going to go the opposite direction, instead of multiplying, I would need to, that's right, you got it, I would need to divide. So I'm going to go ahead and divide. So I'm going to do 756, and I'll do that right over here. So I'm going to do 756 divided by 1.05. And that is going to get me, so 756 divided by 1.05, that gets me 720. I'm noticing I'm a little bit off my screen over here, but that's going to get me, I'm going to switch over to this side. That's just going to get me 720. So that is my starting value. So I'm going to go back and write my equation, y equals, boy, my dog in the background is coughing there. So I'm going to have y equals 720 times, my multiplier was 1.05 to the x. And voila, I am done. All right, let's look at one more problem. So we kind of talked about this. If you joined me in the Zoom meetings this week, I did talk about this. There were some problems where you were just given 2 ordered pairs. So for example, let's say you were given 0, 15, which hopefully people are noticing that that's my starting value. And I was also given the point 6, 20. Okay, so looking at that, those are the 2 points that I have, and I want to write the exponential equation that will work with those 2 points. So I already have, as mentioned, I've got a starting value. It's right here. Okay, so that's going to be my starting value. That's going to be my A. But I don't know the multiplier. Now you might remember in the Zoom meeting I talked about how we could try some guessing. I'm noticing at 0 it's at 15, and then at 6 it's at 20. So it is increasing, but it might take me a while to do a trial and guess on that. So what I'm going to do is I'm going to first go ahead and write out my equation. So I have y equals, I know the starting value is 15, times b to the x. And I don't have that b, but I do have, right, I do know looking right up here that this, okay, that 6 is my x value, and that 20 is my y value. So I do know that. So I'm going to use, you might remember, substitution. I'm going to go ahead and use the substitution method. I'm going to substitute those into that equation. So I'm going to go ahead and put over here, I'm going to have where y is, I'm going to put 20, and I'm going to put 15 times b to the, and instead of leaving x, I'm going to put in 6. Okay, now I need to solve this equation for b. So the first thing I'm going to do is divide. I'm trying to get b by itself. It's being times by 15. So I'm going to divide both sides by 15. That's going to get me 20 divided by 15 is 1.33 repeating. So I'm going to put 1.33 equals, and then when I divide 15, b to the 6th divided by 15, those cancel out, and I have b to the 6th. Okay, so now I gotta solve this. Now you might be wondering, how can I do that? I don't want to divide by 6. Okay, b to the 6th is not 6 times b. It's saying what number multiplied 6 times is 1.33. Now if it was b squared, we'd be trying to find what number multiplied 2 times is 1.33. We could use the square root function on our calculator. Luckily, we're trying to find here what number multiplied 6 times is 1.33. The calculator does have that same feature. Instead of being called a square root button, it's just called a generic root button. So I'm going to go to Desmos. Here's Desmos. And you're not able to quite see, let me see if I can move this over a little bit. Can I move this over a little bit? It's a little bit hard to see on my screen. I'm going to just move this over a little bit. Okay, now you can see my cursor. So at the bottom left corner, I'm going to click on my calculator, and you can see that kind of down here at the bottom. And it's a little bit hard, I'm noticing again on my screen, I'm not being able to show that. Let me see if I can move this over a little bit. All right, let me get my screen here. Okay, I'm gonna, that doesn't seem to want to move over. Okay. All right, well, I'm just gonna go with it. At the bottom right, there's a button called Functions that you're going to see on Desmos, and up is going to come this button right here, and I'm going to go ahead and click on that, and you'll notice that here it is. It doesn't have right up here, I'm going to actually put a 6. That's going to be my 6th root, meaning I'm looking for what number multiplied 6 times. And I was using 1.33. That's what I was trying to find. So I'm going to put in 1.33. And notice Desmos just gives me 1.048. So I'm going to go with 1.05. Happened to be the same multiplier as the previous problem, just by chance. So I'm going to go ahead and use that as my multiplier. All right, so if I go back to that problem that I had right over here. So again, I used, and I'm just going to go ahead and kind of write that out. If I used this feature on Desmos or on another regular calculator, and I put in the 1.33, and I put the 6 out here. Sorry, I know my handwriting here is horrible on the computer, but I'm doing my best I can. I'm going to end up getting 1.048, which I rounded to 1.05. All right, so I'm now going to go back, and I'm just about done. I'm going to write y equals, and I'm going to put 15 times 1.05, and I'm going to put to the x. All right, and that would be my exponential equation. All right, I hope that this is helpful to you, any of my math students, or anybody else who has just come across this video. I hope that it has helped you as well. All right, have a good one.